Loss function. Let us see what is a loss function and what is the purpose of this loss function while training a machine learning model. This is what we are going to learn. Loss function is also called as cost function or objective function. All are one and the same. In this particular lecture, we'll be referring to it as loss function. The purpose of this loss function is this. It helps you measure how wrong is the prediction of your model when it is compared with the actual target. This is the use. That is, if you have a model like this is your model, and let us say you have input data here. From this, you are taking one value and giving to the model. What will the model do at this point? If it gets some input, it will process the input and produce a final output. So whatever is the output that is produced by the model, we'll call this as the prediction that is produced by the model. The next step is you have to see what is the actual expected output, the actual output, and then you want to compare the prediction that is produced by the model with the actually expected output. So it can be the case that actual output is something that is slightly different from what the model has predicted. This is where you have to compare both these values, identify what is the difference between them, and accordingly you have to update the parameters of the model such that next time when the model produces an output, it should be able to produce an output which is closer to the actually expected output. This is the purpose. You can think of it like this. In your school, your teacher will conduct different examinations. Let us say at the beginning of your year, when she completes one particular chapter, she may conduct a class test. In this class test, what happens? The teacher will have some questions prepared. You will answer those questions in your answer paper. And finally, there is something called as marks. What is the purpose of this marks? Using this marks, you will be able to identify how good were you in order to write an answer which is closer to the actually expected answer. Whatever is the actual correct answer, how close are you to this correct answer? In order to understand that, you will use marks. The same way marks is helping in your class test, loss is going to help you in training your machine learning model. Marks is actually helping to train you in understanding a topic. The same way, loss will help the machine learning model in understanding one particular task. This is the requirement. Let us just go back to this marks example. Let us say you got some marks in this class test on one particular lesson. This will help you understand that these are the areas where I lost my marks, because of which I have to concentrate more on these areas so that next time when I have a test, I'll have better marks. What happens after this? Let us say few months passes, then you have quarterly examination. During the quarterly examination, again there will be questions from the same lesson. What happens this time? Because you already had a class test and you got some marks and understood that you lost marks from certain areas, this time you are prepared with those areas. You prepared with those areas, you came for the quarterly exam, and then what happens? Again, there will be some particular areas from where you would have lost marks. This time you are again learning. You are again learning that even after you are learning in the class test, there are some parts in the lesson which you had missed out, from which you lost marks in quarterly examination. Again, you learn those parts, you will be prepared, then you will have half yearly examination. The same process repeats. Will you get full marks there? If you get full marks, that means you are really perfect with the correct answers. But if you lost some marks, that is where you will understand again there is some scope for improvement. Like this, finally, when you write the examination at the end of the year, the final examination, by that point you will have a better version of you who is capable of answering most of the questions on this lesson. So this is how the marks situation works. I just took marks as an example because it is something that all of you will be able to relate easily with. The same way you are having this marks, the machine learning model has what is called as loss. The same way marks is given for whatever is correct. So what is the difference though? Whatever is not correct, those lost marks, that you can consider as loss. So loss means those are the areas which the machine learning model has to improve on. Loss will tell it how much is the improvement to be made. So that is what you have to understand. Minimizing this loss. This is the whole task while you are training a model. How do you train this model? You will try to minimize this loss, and as you approach zero, your model will become better and better. This is the logic. How will you write loss? Let us say, generally we'll denote, let us say some input as y. Input as x and your output as y. If this is the situation, this is your actual input, actual output. That is, for an input x, y is the actual expected output. So your model may come up with something called y cap. So y cap is the output that your model has produced. Then your loss function L, this should be a function of y and y cap. What is the purpose of this function? This function should tell you what is the difference between y and y cap. We'll call y as the y is the true label because this is the actual expected output. What is then y cap? Y cap is the predicted label. This is what is predicted by the model. And this L, this is the loss function. This should tell you how much is the loss when you have y and y cap. That is, y is the actually expected value, but y cap is what your model has predicted. Then how much is the loss in this particular case? Accordingly, your model has to be updated. So this is the purpose of loss function. The next question is, why do you need different loss functions? What is the whole purpose of having different loss functions in training different models? Why can't you simply say, okay, I just want to find the difference, so I'll do y minus y cap. This will give me difference between y and y cap. Why can't you simply use this? And why do you need separate loss functions for different machine learning models? This is what we are going to learn in depth in this lecture and the coming lectures. Okay. So the first thing, you already know this guides the learning process, and without this loss function, the model would have no way to know if it is improving. See, you can improve only if you can understand whether you are in the right path, whether you are improving or not. So if the loss gets decreased after every step, that means the model is actually improving. And another point is that when you do gradient descent is an optimization algorithm. So when you use gradient descent, this loss function's gradient is what you use to update weights. So we'll explain that when we reach gradient descent. At that point it will be clear. For now, just understand that the gradient of this loss function, that will be used in order to update the weights of the model. Okay. There are different tasks. According to the tasks, your loss function will differ. For example, you have regression. Regression is one category of task. Similarly, you have classification. Classification is another category of task. You may also have to do some generative tasks. All these are different types of machine learning tasks, and according to the character of the task, you may have to choose different set of or different family of loss functions. Coming to regression tasks, you have a lot of loss functions. One commonly used loss function is mean squared error, MSE. MSE is a very common loss function, mean squared error. Similarly, you have mean absolute error. This is also another loss function. Here we are only talking about regression tasks. For regression tasks itself, you have all these loss functions. So in the coming lectures, you will see what is the difference between all these loss functions and how to decide which one to use. That is important. Then another can be, you have root mean square error. This is also another loss function. Then you have something called as hinge loss. There is a squared hinge loss. You have KL divergence, all these are loss functions. Similarly, coming to classification, you have cross entropy. That is, if you have binary targets, let us say two targets are the two classes, then you will use BCE, that is binary cross entropy. This is a very widely used loss function. It is also called as log loss. Here I am just naming because I just want you to be familiar with all these. In the coming lectures, we'll deep dive on what each of these are. Here we are just getting familiarized with all these terms, okay? Then you have categorical cross entropy, that is another classification loss function. You have sparse categorical cross entropy, that's also another one. Hinge loss, squared hinge loss, KL divergence, all these are different loss functions. Okay, KL divergence is actually used in classification. It should not be put in regression. Then coming to generative, you have negative log likelihood, that is generally used. Then you have Jensen-Shannon divergence, KL divergence. All these are we'll see in detail in the coming lectures. Okay. So the next lecture we'll see about regression loss functions. Then we'll go in depth about each of the loss functions. Then we'll move on to classification ones and so on. Okay.